All right, 2.7 factoring special products. There are special products when factoring. We have something called difference of two squares. We've kind of seen this before, and perfect square trinomial patterns. So you definitely want to take into consideration and study these patterns because it will help you later on in the future. All right, so our essential question is, how can you recognize a factor and factor a special product? The difference of two squares basically means that you have a squared, you're subtracting from b squared. That's what difference means. And when we see this, we know we're gonna have a positive a plus b and a negative a plus b. So we're kind of working backwards from what you learned in, I believe it was 2.5 factoring. Actually, I don't know what it was. I can't remember. I think it was 2.5. And we were actually starting with this, and we said when we multiply these two binomials, you end up with a squared minus b squared. So we're working backwards. So if you look at example 1, factor, if you take the square root of x and the square root of 25, that will give you your a and b, and then we can go from there. So what you're asking yourself is x squared, taking the square root of x squared tells you that it's x and we're squaring it, and we're subtracting from the square root of 25, which is 5. And so this is your a, this is your b, if you're looking at the difference of two squares pattern. And then we know it's a plus b and a minus b, so it's x plus 5 and x minus 5. Now, if you are so confused and you don't get this by the end of the section, again, it just requires practice, you can fall back on the big X. You have to keep in mind that this, students, is your A. We don't have a B, so instead of putting a 1, we'd put a 0 for B, and our C value is negative 25. And we know that the only number that makes up negative 25 and has, if we add those two numbers up, it'd give us 0, would be 5 and negative 5, and that's where we get the 5 and negative 5. Okay, so if you can't remember these patterns, again, these are super shortcuts, and so try to remember the patterns. Try to be able to identify them. Okay. The square root of x squared is x. Square root of 64 is 8. And then again, this is our a, this is our b, so we know the patterns is a plus b and a minus b, which is x plus 8 and x minus 8. There's your answer. Again, you can check your work and you can figure out this out using the big X. Okay, so it's up to you. Well, what happens if a is greater than 1? So that is going to occasionally happen. You're still going to take the square root of 4x squared. We know the square root of 4 is a perfect square. It's 2. The square root of x squared is x. And then, yes, we can take the square root of 1, which is 1. Again, this is your a, this is your b, so it's a plus b and a minus b. So it's going to be 2x plus 1. And there's your answer. Now, if you happen to switch these, that's fine. If you brought this one forward, that's okay. You're still going to get the same answer. You can also check your work by using the box method, FOIL method, rainbow method, or distributed property method, and you'll get what we started with, 4x squared minus 1. All right, the last one is D. Again, we're taking the square root of 25x squared, which is 5x squared, and the square root of 36 is 6. We've identified our A, identified our B, 5x plus 6, 5x minus 6. And there you have it. All right, the next pattern is a perfect square trinomial pattern. if you have a squared plus 2 times ab plus b squared, there's a plus sign here. We know that this is a plus b quantity squared. So whatever your a is and whatever your b is, sorry, I didn't mean to do that. Your a and your b, it's going to be that quantity squared. The same thing here, a and b, and then if there's a minus sign, if your b value is negative, then we know we're going to have a negative here, or minus sign. It's going to be quantity squared. So again, if you cannot remember these patterns, you can fall back on the big X. We are taking the square root of a, square root of b, that will go here. Again, square root of a, square root of b, that will also go here. Okay, so this is how I usually break it down. I really don't provide anything in the middle, because the middle, it really doesn't matter, because we're focusing our attention on a and b. So, I mean, it's up to you. You can write it out, but, you know, I'm just trying to factor here. Okay, and so you can use the big X. Okay, so we know that if we take the square root of x squared, that gives us x, quantity squared. If you take the square root of 16, that gives you 4, right? 4 squared. Okay, and honestly, we're pretty much done here. If you have identified your a and your b, we know this is a plus sign. And we want to make sure this is 2 times ab. So if a is x and b is 4, 2 times 4 is 8, and then we have 8x. Okay, so we want to make sure this is the only time that you can use it, when you have a, it's called a perfect square trinomial. So your final answer is just x plus 4 quantity squared. Okay, what does that mean? It means it's x plus 4 times x plus 4. That's your answer. Okay, so either one will work. You can keep it like that, or you can break it down. You'll get credit for it. Okay, again, if you are like, I have no idea what just happened, Mrs. Holmes, guess what? You can fall back on the big X. So 16 will go on top, 8 will go on bottom, and then you know our answer is 4 and 4. There we go. We have x plus 4, x plus 4. 4 times 4 is 16. 4 plus 4 is 8. So we know we did it right. And this matches up. Okay. Again, if I take the square root of 4x squared, this gives me 2x. If I take the square root of 3, that's 3. To get this b value, you're multiplying 2 times a times b. So 2 times a, which is 2, times b, which is 3. That gives us 12. And then we have our x here, so 12x. So we know this is right. Okay, we know that this is a perfect square trinomial. We know that we have a negative here. So instead of positive, we're going to replace it with a negative. So if I take the square root of 4x squared, we said it was 2x squared. And if I take the square root of 9, this is 3 squared. Remember that minus sign says 2x minus 3 quantity squared. Okay, again, you can write it out as 2x minus 3, 2x minus 3. They both have to be negative. Please do not put one positive and one negative. Then you're talking about something totally different. Okay, you can also use the big X on this, but you have to keep in mind that a is greater than 1. So you're going to have to use this 4 to create both of your binomials, and then divide out 1, if not 1 both. And then this will be your answer. Okay. All right, we got one more, which is actually solving. Oh, I'm sorry, 2 more. Where we're actually going to solve. So remember, solving is different from factoring. Solving, there is an equal sign, and I forgot my equal sign here. Okay, there is an equal sign. Excuse me. And again, if there's an equal sign, we know that x is actually going to equal a number. So let's go ahead and look at this. This, I recognize it from the previous problem. This is a perfect square trinomial. Okay, so we would use a perfect square trinomial pattern. And so let's go ahead and do this. So we take the square root of x, which is x squared, which would be x. And then we know that the square root of 9 is 3, so 3 squared. Again, it's going to equal 0. So how would I write that out? Well, I know I have x plus 3 times x plus 3 equals 0. Again, from this point, you should know that you're going to set each one equal to 0. And what we have is, x plus 3 is equal to 0. What we have is repeated roots, so we know that x is going to equal a negative 3. So you can just give me x is equal to negative 3. You'll get full credit. Again, this is called repeated roots. Yes, you can fall back on the big X, and you're going to get the same answer. Okay. All right, this one is like example 1 where we're finding where this is the difference of 2 squared pattern. Difference means subtraction, and then we have 2 squares. So the square root of, remember when we break this down, we're going to have an a plus b and an a minus b. It's not just going to be negative. So if I break x, the square root of x squared is x. Square root of 81 is 9. And we know this is x plus 9. X minus 9 is equal to 0. X plus 9 is equal to 0. X minus 9 again, I'm showing my work. I am your teacher, so we're going to end up with negative 9 and positive 9. So there's your final answer. Again, it's asking us to solve, so there is an equal sign. Okay, have a wonderful day.